Hello, Algebra 1. Your homework this evening is to watch this Simplifying Rational Expressions video and to take notes on it. Your notes will be collected tomorrow morning for your homework, to be put into PowerSchool. Let's talk about some vocabulary first before we move on into actually simplifying rationals. You need to know what a rational number actually is before you can manipulate them. So our first vocabulary phrase is a rational number. A rational number is anything that can be written as a fraction. So essentially every fraction is rational. If I say 6 divided by 2, that's a rational. 1/2 is rational. If I say x divided by 4, that's rational. So anything that can be written as a fraction, I can even go so far as to write a binomial over a single term, and that's rational. Anything that can be written as a fraction. So these are all your quick examples. Another phrase is rational expression. An expression is a fraction that's a T. A fraction with a variable or variables in it. So in the examples up at the top, this third one and this fourth one are both rational expressions. They have some sort of unknown mixed into it. Okay? Alright, if you need to continue copying that down, go ahead and hit the pause button, otherwise the video will play on. So, as far as simplifying rationals, you also need to know some rules for simplifying fractions, such as if I have AC over BC, we have that situation where we have a giant 1. C over C is just 1. That's the same thing as A times B times 1. That C over C becomes 1, which just gives you A over B. Your C's essentially cancel out. You might remember that from class. Something from the top of your fraction can cancel out something from the bottom. Something from the numerator can cancel something out from the denominator. Here's an example of that. If I have 5 times 6 over 3 times 6, well, that's just 5/3 times 1, which is just 5/3. That can further be reduced, as you guys know, to 1 2/3. Alright. If you need to copy that down, go ahead and hit the pause button, otherwise the video will play on. So here goes your first example of simplifying some rationals. If I give you the example such as 28x over 7, well, that's the same thing as 7 times 4 times x. 28 is the same thing as 7 times 4. All of that's over 7. Well, that's the same thing as 7 over 7 times 4x, which is just 4x. Okay? So there's your giant 1 for your 7, leaving you with just a 4x. So we're manipulating a rational expression so that we simplify it and get rid of stuff that cancels out. Let's take a look at another example, like 2x over 8x to the third power. Well, I can look at it like this. I have 2x, over 4 times 2, and that's x times x squared. 8 is the same as 4 times 2, and then x to the third is the same as x times x squared. Well, you can draw your giant ones. Here's 2. In fact, there's another giant 1 over those x's. When you get rid of those, I don't have anything on my numerator anymore, so it becomes a 1. And on the denominator, I'm left with a 4 and an x squared. Alright, if you need to continue copying, go ahead and pause it. Otherwise, we'll see some more examples here. Okay, so on these examples, we want to be able to continue with that simplification process, except our expressions are a little bit more complicated. So let's take a look at this problem. 4m over 4 times m minus 6. So when we simplify this, remember, things need to be multiplied in order to cancel them out. So if I try to draw my giant 1, I have a giant 1 over here, a little slanted giant 1, my 4 and my 4, leaving me with just an m on my numerator and an m minus 6 for my denominator. Notice I cannot cancel out my m's. That does not work. The reason is this is not a multiplication symbol. That needs to be multiplication to cancel it out. Here's a side example. Let's say that m is equal to 2. So we have 2 over 2 minus 6. I cannot say I'm going to cancel out a 2 on the top and a 2 on the bottom to equal 1 over negative 6. It doesn't work out that way. When you actually do the math of it, you see that you get 2 over negative 4, or negative 1/2. That's the correct way. There's a nice big check mark. This is the incorrect way. I cannot cancel out top and bottom, numerator and denominator, if multiplication is not involved. You need to have that multiplication. Let's see if I can highlight that for you. Needs to be multiplied to cancel it out. Okay, let's do another example here at the bottom of the page. So on this example, I have 5b over 10b squared minus 5b. I can't start canceling things out because, again, I need that multiplication. It's not there. There's no multiplication yet on the bottom, which means I can still factor. Well, I would need to factor. So like we practiced in class, I'm going to go and factor that denominator. I'm going to factor out a 5 and a b, leaving me with a b and a negative 1. Essentially, this is the reverse of the distributive property. take that, put it in there. You want to check your work, you distribute it. Well, now that I have that multiplication there, I can go ahead and do my cancellation. I have a 5b on top and a 5b on the bottom. Well, that leaves me with just a 1 on my numerator and a b minus 1 on my denominator, and that's my final answer. Alright class, that's all the examples we're going to take care of today. That's your new concept, how to start simplifying rational expressions, starting off with some relatively simple ones, moving on to some that are a little bit more complicated. Thanks for listening. I'll see you in class tomorrow.